Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying binomial lecture 1. So let us start with the basic definition of binomial expression. So any algebraic expression which contains two dissimilar terms is called binomial expression. For example, let's say x plus y or a plus b. We won't be calling x plus x as the binomial because these are not too dissimilar. These are similar terms and they can be added. So this is not a binomial term. So for that, for an expression to be a binomial expression, we have to have two dissimilar terms, right? Now let us talk about factorial. Although everyone must be knowing about factorial, but let's formally define it. So factorial of a natural number n is the product of first n natural numbers. For example, if I'm defining factorial for 6, I'm writing 6 factorial. That would mean 6 into 5 into 4 into 3 into 2 into 1. This is how we have to write. And one property you can see that with the obvious observation is that is 6 into 5 factorial. This expression becomes 6 into 5 factorial, right? So basically, any factorial n factorial can be written as n into n minus 1 factorial. That is one important property of factorial, right? Now here are a few important results. The second property n factorial equals to n into n minus 1 factorial we have already talked about, and the first property, that is 0 factorial equals to 1. This we'll be talking about a little later, right? And we'll be talking about this first property after discussing NCR. So let's before defining NCR mathematically, let's try to understand the idea behind NCR. So basically, it means selection of R objects out of n available distinct objects. Here, distinct is the keyword. You don't have to miss this keyword in any of the questions which we are going to solve in binomial and specifically in PNC, right? So selection of R objects out of n available distinct objects. Let's say we have distinct objects, 4 distinct objects, let's say A, B, C, and D. We have 4 distinct objects and I have to select 2 objects from here, from these 4 objects, okay? So how would we do that? I can select AB, I can select AC, I can select AD, I can select BC, BD, and CD. So these are the 6 ways we can select two objects out of these 4 distinct objects. Similarly, if we have been given A, B, C, D, E, and if I have to select 3, then I'll be doing ABC, ABD, ABE, and so on and so forth. But you can see that it would be quite difficult to write them manually. So there has to be a way where we can write these things with a formula, or basically with the help of mathematics, right? So that is where NCR comes into picture. So if I try to write NCR for this particular query, that we have to select 2 objects from these 4 different objects, that then I'll be writing 4C2. So basically 4 is the number of available objects and 2 is the basically number of selections which we have to make. So the form, according to the formula, that would give me 4 factorial divided by 4 minus 2 factorial 2 factorial. So basically NCR is n factorial divided by n minus r factorial multiplied by r factorial. So this is how NCR is being defined, and that means selection of r things out of available n distinct things. Okay. So if you calculate this, you'll be getting 6 as the answer. Okay. Now a few interesting things about NCR. So in this case, n is always greater than equals to r. N belongs to natural number and r belongs to whole numbers. Okay. So these are the 3 things which you have to remember for NCR. N is always greater than equals to r. N belongs to natural numbers. R belongs to whole number. Okay. And also NCR equals to NC n minus r. So this is also true. You try to write the formula for both of them and you'll find that mathematically both are same. So basically, if I'm writing 4C1, so that basically means 4C3. So we can use this trick for calculation, for saving our time in the calculation. Okay. Now here comes the important part. That was 0 factorial. Now tell me one thing. If we have 4 different objects and if I have to select all 4 of them or none of them, right? There are 2 cases. Let's take the first case. We have to select all 4 of them. And that would be just one case, because that would be just one way to do it, right? Because if we are selecting all 4 of them, we can do that in just one way, right? So basically, if we are selecting all the 4 objects, The answer should be 1. But if I try to write it mathematically, that would give me 4C4, right? And that would be 4 factorial divided by 4 factorial multiplied by 0 factorial. Now this gets cancelled out and this is 1. So this means 0 factorial has to be 1 to satisfy this condition, right? And now since we have talked about basic things about NCR, factorial and the binomial expression, let us talk about binomial expansion. So you all must be knowing that x plus y whole square would be x square plus 2xy plus y square. X plus y whole cube would be x cube plus y cube plus 3x square y plus 3xy square, right? So we know these formulas from 9th and 10th class, but what if we have been told to find x plus y raised to power 10? Then we won't be able to do that, right? Because we don't really know the formulas of these kind of equations, these kind of expressions, and they will be too lengthy to write. But there has to be way with the help of which we can find out the value of these kind of expressions. Basically, we can expand these kind of expressions. So that is where binomial expansion comes in picture. So how do we define binomial expansion? So let's say we have to expand x plus y raised per n. In that case, that would be nc0 x raised per n minus 0 y raised per 0 plus nc1 x raised per n minus 1 dot y raised per 1 and till the end. So you can clearly see that it is starting from 0 and it is going till n. So basically it should have n plus 1 terms. If it was starting from 1 and going till n, then it would have had n terms. But since it's starting from 0 and ending with n, that is this entire expansion will be having n plus 1 terms. So it will be having n plus 1 terms. So how do we define the general term for this expression, this expansion? That would be tr plus 1. That would be ncr, right? Dot x raised per n minus r dot y raised per r. You can see that for 0 for the first term, basically that is tr plus 1. For the first term, it's 0. For second term, it's 1 because we have defined tr plus 1 over here. Now similarly, you can write this expansion for x minus y raised per n. And all you have to do is just replace y with minus y. You can rewrite this as x plus minus y raised per n. Whenever we are doing any kind of expansion, binomial expansion, we'll be rearranging our terms like this and we'll be treating plus in between and anything over here as with the sign, right? Okay. So that is how we have written this expansion. Now let's look at one example. If 1 plus ax raised per n equals to 1 plus 8x plus 24x square, then find the value of a and n. Right? So we'll be writing the expansion for this one. So that would give me nc0 dot 1 raised per n minus 0 dot ax raised per 0 plus nc1 dot 1 raised per n minus 1 dot ax raised per 1 plus nc2 dot 1 raised per n minus 2 dot ax raised per 2 and so on. We just need the terms till x square because over here we have been given only 3 terms till x square only, and we have to find just 2 variables. So we can find out these 2 variables with the help of given information. Now let's compare it. So this is 1 only, nc0 is 1, nc0 is 1, we studied that, and this is 1 only. So basically this is 1, this is 1, and this is also 1. So basically the first term is 1. So we don't have to do anything with this first term. Now second term, in second term nc1 would be n, and 1 raised per n minus 1 would be 1, and ax raised per 1 would be ax only. So this one we have got a n x, and that is equals to 8x. Now the second term, that would be nc2. nc2 would be n minus 1 divided by 2 factorial. I have done the shortcut. You can refer to any book for the shortcut. So you can write nc2 quickly like this, rather than writing n factorial divided by n minus 2 factorial multiplied by 2 factorial. You can write it like this, multiplied by 1, and that would be a square x square, right? And this is equals to 24x square. This gets cancelled. Now let's multiply these terms. So we'll be getting n square minus n multiplied by a square equals to 48. So a square n square minus a square n equals to 48. So a n was 8 over here. So basically in a square n square would be 64. So 64 minus 48 equals to a square n. That is a dot a n. A n again is 8. we'll be writing that as a dot 8, right? So this would become a dot 8 equals to 16. So a equals to 2 from here. And if a equals to 2, then n would be 4, right? Now let's review some properties of binomial expansion x plus y raised to power n. So number of terms in the expansion is n plus 1. We have already talked about it. The sum of the indices of x and y in each term is n. So this is important. So basically, if I am writing tr plus 1, so that would be ncr dot x raised to power n minus r dot y raised to power r. So if you add the indices of x and y, then you'll be getting n as the answer for every single term. The binomial coefficients nc0, nc1 of the terms equidistant from the beginning and the end are equal. That is again very obvious. Let's try to write it for a general term. So let's say the first term would be nc0 dot for x plus y raised to power n equals to nc0 dot x raised to power n minus just n and y raised to power 0, plus the second term would be nc1 dot x raised to power n minus 1 dot y raised to power 1. And if I write the second last term, we'll be getting ncn minus 1 dot x raised to power 1 dot y raised to power n minus 1 plus ncn dot x raised to power 0 dot y raised to power n, right? So these are the last two terms. These are the first two terms. So now if I'm going first place from the left side and first place from the right side, basically first place from the beginning and first place from the end, basically equidistant from the beginning and end. In that case, this is the coefficient, this is the binomial coefficient, and this is the binomial coefficient. So before defining these, so I just forgot to add one thing. So whenever we are defining a general term, our general term tr plus 1 equals to ncr dot x raised to power n minus r dot y raised to power r. So this is called as binomial coefficient, right? So you have to remember that ncr is called as binomial coefficient. And if there is some term like in place of x, let's say there is 2x, and when we are opening the powers, we'll be getting ncr dot 2 raised to power n minus r, then this entire term is called as just coefficient of the binomial expansion, and this term is called as ncr is called as binomial coefficient. Now let's move back to the problem. So basically it is saying that terms equidistant from the beginning and the end are equal. So we know that ncn and nc0 and ncn are both equal because ncr equals to ncn minus r. So you can see that this is nc1, this is ncn minus 1. So both are equal because of this property, right? Now let's talk about general term, which we have already talked about. I'll write it formally once again. tr plus 1 equals to ncr, basically binomial coefficient multiplied by x raised to power n minus r dot y raised to power r. So this is how we define the general term, and we know that there are total n plus 1 terms in case of x plus y raised to power n. Now let's look at one more example. If the fourth term of the expansion px plus x raised to power minus 1 raised to power m is 5 by 16 for all x belongs to R, then what are the values of p and m, right? So we'll write the fourth term for the expansion. So t4, basically fourth term would be mean 3 plus 1, right? So R value would be 3 over here. So that would mean ncr basically, sorry, ncr dot px, this is called as capital X, this is called as capital Y. So capital X raised to power n minus r, that would be m minus 3 dot x raised to power minus 1 raised to power r, that is 3. And the fourth term is 5 by 16. That essentially means it doesn't have any kind of x component. So let's write it once again. This is not n, this is m. mc3 dot, that would become p times m minus 3 dot x times m minus 3 and minus 3 from here m minus 6. Now we know that this term is not having any kind of x term. This time is independent of x. So that basically means this power of x should be 0. So basically m should be 6. So that is our first part. Now let's try to find out the coefficient, because this coefficient should be equal to 5 by 16. So 6c3 dot p raised to power minus p cube, that should be 5 by 16. So this essentially means 6.5.4 divided by 3 factorial dot p cube equals to 5 by 16. 3 factorial is 6, so this gets cancelled out, and this 5 gets cancelled out. So p cube equals to 1 by 64. Basically p equals to 1 by 4 is the correct answer. So B is the correct answer. Now let's talk about this example. The term independent of x in the expansion, this will be. So let's write TR plus 1. That would be x raised 10 CR dot x by 3 raised per half times n minus r dot 3 by 2x square raised to power r. And we have to find a term independent of x. So basically we have to add the powers of x and make them 0, right? So 10 CR dot 1 by 3 raised power n minus r by 2 dot x raised power n minus r by 2 dot. I'll write the coefficient first, the constant terms first. So that would be 3 by 2 times r dot x raised power n minus r by 2 dot x raised power minus 2r, right? So this, let's say this term is called as k dot, this would become x raised power n minus r, and that would become minus 4r by 2. So basically n minus 5r by 2, right? Now this term would be independent of r. N over here is 10, sorry, I haven't written 10 over here, but n is 10 over here. So 10 minus 5r should be 0. So basically r equals to 2 over here. Now we have got the value of r, you can find out the value of coefficient. Now let us talk about term from the end. So we have this expansion x plus y raised power n, that is equals to nc0 dot x raised power n dot y raised power 0 plus nc1 dot x raised power n minus 1 dot y raised power 1 plus nc2 dot x raised power n minus 2 dot y raised power 2 till ncn minus 1 dot x raised power 1 dot y raised power n minus 1 plus ncn dot x raised power 0 dot y raised power n. Now what if I write y plus x raised power n in a similar format? I'll be getting nc0 dot x raised dot y raised power n dot x raised power 0 plus nc1 dot x y raised power n minus 1 dot x raised power 1 plus nc2 dot y raised power n minus 2 dot x raised power 2 till ncn minus 1 dot y raised power 1 dot x raised power n minus 1 plus nc n dot y raised power 0 dot y raised power n, right? Now we have to find out term from the end. Let's say they are asking you to find out the second last term. So second term from the end. So basically they are asking you to calculate value of this term or the coefficient of this term. Now since this entire expansion will be having n plus 1 terms, so there can always be confusion in finding out the correct value of r. So the better way to do it, rather than applying your brain over here or trying to do the mistake calculations, the better way to do is to write this reverse equation and find out the second term from the first. So you can clearly see that this is ncn minus 1, this is nc1, and we know that ncr equals to ncn minus r. So this binomial coefficient is same for both the terms. This is second last term, and this is the second term from the for the reverse equation, reverse expansion. And this is y raised power n minus 1, this is y raised power n minus 1, this is x raised power 1, this is x raised power 1. So basically the entire term is exactly same for this equation, but the only thing is you have to write the entire expansion in the reverse manner. So basically you have written over here x plus y raised power n, and you have to write for y plus x raised power n for calculating the term from the end. So let's see one example. The fifth term from the end in the expansion, x cube by 2 minus 2 by x cube raised power 9. You'll do it as homework, but I'll just give one caveat over here. So basically, so over here x equals to x cube by 2 and y equals to not 2 by x cube. It's actually minus 2 by x cube, right? So when you are writing y plus x raised power 9, the reverse expansion, you have to write minus 2 by x cube plus x cube by 2. So as I've told earlier, you have to consider plus sign over here, x cube by 2 plus minus 2 by x cube, and that should how your expansion should be written. So in the case of reverse expansion, that would become minus 2 by x cube plus x cube by 2 raised power 9. And then you can find out the fifth term from the first, right? So today's lecture was still here only, and in the tomorrow's lecture, we'll be talking about middle term and the numerically greatest term or coefficient. So let's meet tomorrow. Thanks for watching.